Problem 51, we're taking a look at some inequalities. We're going to try solving them and then representing our number on a number line. We're also going to write out the answer with the inequality. First thing we want to do is we want to find what's called the boundary point. The boundary point is when you're making your number line, it's the number that has either the open or the closed circle on it. That is your boundary point. To figure that out, we actually want to figure out when, instead of this being an inequality, when is it equal? So I'm going to take 2 times 3p plus 1 and figure out when does it equal negative 4. I'm going to distribute the 2 here and get 6p plus 2 equals negative 4. Move the 2 by subtracting it from both sides. And 6p equals negative 6. Solving for p, then, I get p to equal a negative 1. What that means is that negative 1 is now my boundary point. So that's where my circle is going to go. If you look at the original inequality, it is a greater than symbol. If it's not or equal to, that means it's going to be an open circle on negative 1. What I want to do now is I want to test some values to see which way to shade our number line. A real easy number to always try testing is 0. So I'm going to test 0. 0 would be right here to the right of negative 1. To the left would be a negative 2. So I'm going to test 0 in my original inequality. So I have 2, and in parentheses 3 times 0 plus 1, is that greater than negative 4? So 2 times, all of this here inside of the parentheses becomes 1. 3 times 0 plus 1 is going to be 1. So now I have 2 times 1, is that greater than negative 4? 2 greater than negative 4? And that is true. 2 is greater than negative 4. So what that means is I am now shading to the right. So my solution on a number line is right here. My solution written out algebraically then, since we're dealing with the variable p, it's going to be p is greater than negative 1. I'm going to do the same thing for problem B. Finding my boundary point, I'm going to make it an equal symbol. 9k minus 2 equals 3k plus 10. I'm going to move the 3k to the other side by subtracting it. 6k minus 2 equals 10. Add the 2, and 6k equals 12, and then dividing by 6 gives me k to equal 2. So now 2 is my boundary point. Again, I have a symbol here that is not or equal to. This is a less than symbol. So again, it's going to be an open circle because I'm not including my boundary point in my solution. If I think about where 0 is located, it would be now to the left. So to go through and substitute in that 0, I will have 9 times 0 minus 2 less than 3 times 0 plus 10. That cancels out. I have negative 2 is less than 10. Negative 2 is less than 10. That is also true. So I'm now shading in the direction of 0. If I tested another number, let's say I tested 3. 9 times 3 minus 2, is that less than 3 times 3 plus 10? I would have 27 minus 2 less than 9 plus 10, and I would have 25 is less than 19. That is not true. So that means I do not shade that direction. I'm going to try problem C next. Oh, I need to finish writing the answer out for this problem. Sorry. So I know the boundary point is on 2. So I have k. I'm going less than 2. Problem C. Now this one's the real important one here to make sure we are setting this as an equal symbol. So I'm going to go through and subtract the 5. And I have negative h equals negative 1. And when I divide by negative 1, I get h to equal 1. One is now my boundary point. Now, this one is or equal to because of the little line that's underneath it. So it is a greater than or equal to symbol, which means I am now shading in my circle. I am including the boundary point in the answer. Testing 0 for this one. I now have 5 minus 0 is greater than or equal to 4. 5 is greater than or equal to 4. That is true. So I am going to shade in that direction. Testing a number on the other side, again, just to prove the other side does not work. 5 minus 2, is that greater than or equal to 4? 3 greater than or equal to 4. That does not work out. I do not shade that direction. So my solution, h, I'm going less than, and I'm including it, my boundary point of 1. So h is less than or equal to 1.